Okay, so first you're going to look at your limits, which is 3 pi, which is down here, to 2 pi, which is down here. And so since your limit is between these two, you have to shade off everything else around it. And then since you're given the cosine of 3 over 5, you then go down and make a triangle with your theta in this corner. And then I always write out SOHCAHTOA to help me remember it. Oops. So since cosine, it would be adjacent, so 3 would be adjacent, and 5 is the hypotenuse. Then you have to figure out this missing side using the Pythagorean theorem, which you then do 3 squared plus b squared equals 5 squared. 3 squared is 9 plus b squared equals 25. Then you subtract 9 from both sides. Then b squared equals 16. Then once you square root both sides, b will equal 4. So then b goes into this side. Then you then plug in your triangle into the circle, and theta is always in this corner. So once you add your triangle, theta is here, and then you just copy your triangle into here. So then this one would be 4, this one would be 5, and then this one would be 3. And then since this is going down, your 4 would then be negative. And then, so once you have your triangle, you would then look at here, and so you see that your sign is opposite over adjacent, so opposite is a negative 4 over hypotenuse, which would then be 5. And then your tangent is opposite over adjacent, so your opposite is once again negative 4 over adjacent, which is 3. Then, now that you have your tangent, you can then go and do your cotangent. And cotangent is the opposite, so these two are flipped. So then you would have a negative 3 over 4. And then there's a square, so you have to square both of them, which would then make this both positive. So you would have 9 over 16. Then your secant is the opposite of cosine, which you were given cosine over here. So then the opposite of cosine would then be 5 over 3. And then your cosecant is the opposite of sine, which then would be your sine is 5 over 4, or your sine is 4 over 5, and then the opposite would be negative 5 over 4. And then once you square both of them, you would get a 25 over 16. And then your sine squared would just be this squared, so it would be 16 over 25. We are now moving on to number 2. And in number 2, we are also given the domain restriction, which is the same as number 1, which is 3 pi over 2, which is down here. So I wrote it in my unit circle, to 2 pi, which is here. And so anything in here in between here is what we're going to be finding out, and so the rest you can just cross off, like the previous problem. So now that you have your unit circle ready, you can then go look here, which you're now given the sign instead of the cosine like we were given in number 1, and you know that the sign is opposite over adjacent. So then we go and write our triangle, and you put theta in the right corner, and then opposite from theta is 9, and then the hypotenuse is 11. But since you have a missing side, you have to go down and do Pythagorean theorem once again, and then you do 9 squared plus b squared equals 11 squared. 9 squared is 81 plus b squared, and 11 squared is 121. You then subtract 81 from both sides to give you 40 equals b squared. Then you square root both sides to get b equals the square root of 40. Then the simplified version of square root 40 is then 2 square root 10. So your 2 square root 10 then goes on this missing side right here. Now that you have your triangle complete with all the sides, you can now enter it into your unit circle. And with your unit circle, you'll know that this is now a -9 because it's going down, and this stays positive because it's going to the right. So now that we know that, we can go over here and know that cosine is adjacent over hypotenuse, so it would be adjacent to theta, which would be 2 square root 10, and the hypotenuse, which is 11. Then when we go over to tangent, you know that it's opposite over adjacent, so opposite of theta is 9. But now that we have it in our unit circle, you know that it's a -9 because it's going down, so we write a negative over adjacent, which is 2 square root 10. Now that we know the tangent, we can now figure out cotangent squared. Cotangent is just the tangent switched. So the cotangent would be 2 square root 10 over -9, and then square both the top and bottom, you will get 40 over 81. Then the secant is just the opposite of the cosine, which we found out over here. So the opposite would then be 11 over 2 square root 10. Okay, and then cosecant is the opposite of sine, which we were given up here, squared. So it would be cosecant would be 11 over 9, and then squaring both sides of those, and then the 9 would be -2. Squaring both sides, you would then get a 121 over 81. Lastly, you know that you already found the cosine, so now you just have to square both the top and bottom, which you would then get 40 over 121. We have now moved on to number 3, and unlike the last two, we are now given a different domain. So now pi over 2 is up here, and then 3 pi over 2 is still in the same spot. So anything in between here is what we're trying to find, so you cross off the other side. Then we are given the cosine, so that with that we know that it's adjacent over hypotenuse. So then we plug these numbers into our triangle, and to find the missing side, once again you use the Pythagorean theorem, and with that you have 2 squared plus b squared equals 7 squared, which is then 4 plus b squared equals 49. Then you subtract 4 from both sides, giving you 45 equals b squared. Then you square root both sides, giving you the square root of 45, which then simplifies to 3 square root 5. So then you plug 3 square root 5 into your triangle here. Then with this triangle complete, you can now put it into your unit circle, and the theta once again goes in each corner right here. Since we have both sides, you can do 2 triangles. And then opposite is square root 3 over 5, or 3 square root 5. The hypotenuse is 7, and then this side is 2. And then both of these triangles are the same. Now with our triangles in the unit circle, we can now go over and answer these. So the sine is opposite over hypotenuse. So the opposite of theta is 3 square root 5. But since we have 2 triangles, this is negative, but this one's also positive. So we write plus or minus in front of it because it could be either one. And then the hypotenuse, which is 7. Since tangent is squared, you don't need the plus or minus or plus. So you have opposite over adjacent, which is 3 square root 5 over 2. So 3 square root 5 squared is 45, and then 2 squared is 4. Then cotangent is the opposite of tangent, which was 3 square root 5 over 2. So the opposite of that would then be 2 over 3 square root 5. But once again, because we have a negative 3 square root 5 and a positive, you would then put a plus or minus in front. Then cosecant is the opposite of sine, and sine we know is opposite over hypotenuse. So opposite would be 3 square root 5 over 7. And since, once again, the 3 square root 5 could either be a positive or a negative, you write the plus or minus in front of your answer. Then secant squared is the opposite of cosine squared. So the cosine was 2 over 7. So, but you flip it since it's the secant, which would be 7 over 2, and then you square both the top and bottom to get 49 over 4. Lastly, you have your sine squared, which you figured out your sine up here, so you just square the top and the bottom to give you 45 over 49. Now pause the video to try number 4 on your own. And this is number 4.